Okay, so it's the material in section 12.2. And okay, so as we say in section 12.2, the difference between section 12.2 and section 12.1, the difference is that if we consider the function g equals f of sy, we consider it's the value of this study, the value of this study, and we consider the double integral. And first of all, it's double integral, so it's the area. Here, A means area, the area. And by Fubini in section 12.1, we know that it's equal to repeat integral. And we could integrate y firstly, and after that, integrate x. And it's also equal to integrate for the function f, integrate x firstly, and after that, integrate y, after that, integrate y. Okay, and the region how we integrate, the region for the function f, xy sy belong to the region R, and the region R is a rectangle. The region R is a rectangle. AB cross CD, AB cross product CD, AB product CD. And the difference in this part, the region. Now we consider general region, not just rectangle. Now we consider general region. But we still have this result. This result will call it Fubini. Originally, our value is defined by this way. It's the double integral, and the A means the area. Use the area. Actually for the region, we can as we say in section 12.1, for the x we divide it into n subinterval, and the y we divide it into n subinterval. So for each one we have a rectangle. We have several rectangles. So we consider sum of the rectangle and let n approach infinity, and consider its limit. Then it's our value, and it's the definition about double integral. And Fubini said that it's equal to repeat integral this one, and it's also equal to repeat integral this one. But here, we integrate y firstly. We integrate y firstly. But when we integrate y firstly, it means that we should what should we do? We should fix x, right? So in this part, we should fix x. So we should fix x firstly, and when we fix x, now the function f of sy, the function x is a constant. You could view x as a constant. So we integrate y. So that's why we say for this equation, for this one, we integrate y firstly, and after that we integrate x, right? And here we integrate x firstly, and after that we integrate y. But when we integrate x, we should view y as a constant. So that's why we wrote here, fix y firstly. When we integrate the x, we should fix y firstly. Okay. Yeah, and now if we change the region, we have general result. But for the general result, we still have the Fubini theorem. For the double integral, it's also equal to repeat integral. But now probably the general region is not rectangle. So you should know how to write down the D. Let's see the difference. Okay, and I explain it by the graph. It will be better to understand what's the difference. So in this part, what does it mean? As we said, we fix x, and x belongs to s between a and b. So s between a and b. We still use the same rectangle, the same region. Here, the double integral, its region is this one, rectangle. And we still use this rectangle. But for this part, what does it mean in the graph? It means that we should fix, as we said, we should fix x first of all. So fix x between a and b. And when we fix x, we consider it's something like we view x as a constant. So for example, x equals 1. Then we consider f of 1y dy. Y goes from c to d, right? Y goes from c to d. So that's why we write what I wrote here. We fix x, and y goes from here. For this part, we integrate y, and the y goes from c to y to d. So y equals c, integrate y equals d. from this line, y equals c, integrate this line, y equals d. Y equals d. We fix s, and from this line, integrate from this line to this line. So integrate from y equals c to y equals d. Right? And as you see, yes, so of course c is smaller and d is larger, right? D is larger. And you also could say c is in the d is upper, and the c is lower, c is lower. Okay, from lower to upper, from bottom, or it will be better to, as we say it, bottom to, it's bottom, and it's top. Okay, so it's bottom. Y equals c is something like the bottom. It's the bottom, and it's the top. Okay, and how about this one? For this one, we integrate x firstly, but when we integrate x, we should fix y. So that's why we say firstly we fix the y, and then the variable y we fix it should be between c and d. For example, y equals 1, and we consider a b f of x1 dx, this term, this one. We fix y, for example, we fix let y be 1, and integrate the function f of s1, and s squared, and se from s equals a to s equals b. Okay, so fix y, and we integrate from s equals a to s equals b, from the line s equals a to the line s equals b. Okay. But now let's see the difference. Here we for this result we fix x and x between a and b, and now we integrate y. Our variable is y, and the bottom function is y equals c. The top function is y equals d. But now we could change it. I mean, we could replace y equals c by y equals g1x, and replace y equals d by y equals g2x. So it becomes this region. D becomes this region. X is still between a and b, but y between g1x and g2x. Then we have this one, and it will be similar, but it will be complicated. Right? And you will see we integrate y firstly, and after that we integrate x. Right? So for this time we integrate y firstly, and when we integrate y, we should view x as a constant, and after that it's a function of x, and we integrate x. So finally it's a number. And as we say, value of course is a number. So if you see the upper bound and the lower bound, if you see the bound, this part the variable we integrate y firstly, and the last one we integrate is x. So for the bound, it should be number. For this part, it could not be a function. If it's a function, for example, g1x or g2x, something else, or g1y, then when you plug in the function, then it's not a number, right? So for this bound, it should be number. But this bound, of course, it could be probably it's the function. It should be the function, and here it must be number. Okay, so it's the same. We fix x firstly, and when we fix x, we integrate y. So we integrate the function y equals g1x to the function y equals g2x. So it's the bottom, and it's the top. Okay, it's the bottom and it's the top. Okay. And this part is the same. We have the similar result. I mean, here we fix y firstly, and we integrate x, and x goes from a to b. So integrate the line s equals a to the line s equals b. So x equals a is left hand side, and s equals b is right hand side. Right? And of course, s equals a should be the smaller, and the s equals b be the larger, of course. Yeah. And then here, for this part, we replace s equals a by s equals h1y, and replace s equals b by s equals h2y. So here the difference is this part. h1y, s we integrate x firstly, and x between h1y and h2y. In other words, we integrate x from s equals h1y to x equals h2y, and after that it's a function of y. It's a function of y, and we integrate y from c to d, from c to d. So again, it's the smaller and it's left hand side. Here is the left hand side. We integrate from s equals h1y to the function s equals h2y. And its left hand side is right hand side. Left hand side is right hand side. Yeah. And Fubini tells us if f is continuous, its double integral equals, here D is the region. D is the region R. D is the region. D is the region. Here D is the region. If we continue on this region, then double integral equals this one. We could integrate y firstly, and after that integrate x. But we also could say that if the region D, we could express it in this way. But we also could express it in another way. For example, this way. In this way, let's mean the same region, but you should know what's the function g1, g2, and what's the function h2, h1, h2. And for the double integral, it's equal to this one, and it's also equal to this one. And of course, it will be a little complicated. Yeah, and probably I will ask you, in this section, I will ask you this, the question I will ask is that, we want to integrate a function, consider its double integral, or consider this repeat integral. But if probably we will, in the original problem, we will integrate y firstly, and after that integrate x. But for the function, when we integrate y, it will be complicated, or actually we could not solve it properly. But we could use Fubini to change the region. I mean, we could interchange x and y, but you should know what's the function, what's the corresponding h1y and h2y. When we interchange x and y, the region will be changed. And no, the bound will be changed. We still use the same region, but the bound will be changed. So you should know how to change the region. And when we interchange x and y, for the function, if we integrate by x, probably it will be easy to solve it. Okay. Originally, we integrate by y, it's complicated to solve it. But if we can integrate by x, firstly, then it will be easy to solve it. But the question is how to know the region, because how to know the bound. For the bound, we should change it, and it will be complicated. Yeah. And I will tell you. Yeah.